Okay, we are proving identities. Now, this is not like your typical geometry type proof, so don't panic. This is more some algebra skills, basically. I'm using these trig identities over here on the right, and I'm using some basic algebra skills to try to turn all of this stuff here into 1. Okay? And we're not asking you if this is like, yes, does it work? No, does it work? Okay, it works. But what can I do mathematically to turn all of this stuff in the left here into the number 1? Now, I have a couple options, and there's different routes of sometimes getting to the same answer. Some people might try this. They might try to distribute. Okay. I always look at the table and say, is there anything I could change first? Like, I notice that I have sine squared and a 1 involved here. And anytime I notice that I have a squared and the number 1, I always refer to the Pythagorean identities here. So the one I like that I notice is right here. All of that is going to turn into cosine squared. So if I rewrote this, I have secant squared of x times, it was 1 minus sine squared. Now it's cosine squared of x. All right, the next thing I would notice is that this top table, okay, the reciprocal identities or the quotient identities also work with squareds. Okay, so for example, like tangent here, I could square the left side and square everything on the right side, and it would also hold true. Now, the one I am looking at here is secant squared. So secant squared, my only option would be 1 over cosine. And again, if I wanted to throw a little squared in here, and I could square the top, but that doesn't do anything for me. 1 squared is just 1, and I square the bottom. So all of this here is going to turn into 1 over cosine squared of x times cosine squared of x. And you'll notice these cancel out. Now, when everything cancels out and I'm multiplying, okay, everything turns to 1. Final answer. Does not turn to 0. Be careful unless I'm subtracting. Okay, 15. Similar type of problem. What can I do mathematically and using these tables over here to the right to change that into tangent squared? So I'm going to go ahead and probably I would start off by distributing. So let me scroll up a little bit. I'm going to do first, outer, inner, last, because I noticed the 2 binomials here. Okay, if I were to distribute, I would get secant squared of x. That's my first terms. You'll notice my outers and my inners, okay, are going to cancel each other out. My outers would give me -1 secant of x. My inners would give me +1 secant of x. And then my last terms would give me -1. And you'll notice these are going to go away. So now I have secant squared of x minus 1. Now, conveniently, you'll notice, again, anytime I incorporate a squared with a 1, I'm going to check the Pythagorean identities. And I see secant squared minus 1. It's right there. So all of this is equivalent to tangent squared of x. And I just did a proof to show that the left side is equivalent or equal to the right side.